Oh, hello there, and welcome to a brand new section, Section 7, Advanced Building Blocks Part 2. So, let's go to a very quick section overview. We are going to see everything that we're going to learn in this section. Now, of course, this is the continuation of the section that we had before, the Part 1. So, we're going to continue to see those Lego bricks, those advanced Lego bricks that we were seeing. And in this section in particular, we're going to see more details about advanced API modeling, so how we can better model our problem into our models and later into our APIs. Okay, we're also going to see how to implement nested resources, which is something very useful that might come in handy when designing the models of your API. So you need to take that into consideration, that might be necessary to have nested resources to have a perfect modeling of your API. And we're also going to take a look at the HOS. So we're going to see what the hell are these letters, what do they mean, and whether we should use it or not in each case, and how to actually implement it if we decide that we need to use it. Okay, so this is what we're going to learn in this section.
In this video, Advanced API Modeling, we're going to take a look at better ways to model and to structure our APIs. So our goal for this video is to understand how to model real-life problems and to create REST APIs that can solve those problems. And the first keyword that we have here in order to model our API is structure, So what is the structure of our models? What exactly makes a resource in our APIs? Let's say I have this problem and I need to save things to the database, for example. And then I have this clear view of my database, and I have tables in my database. And each table, it's an entity in my code, and each entity in my code is a resource in my REST API. So this is a very linear one-to-one mapping that you can do. You can go this route, but maybe that doesn't make a lot of sense to your application. Maybe you want to have some layers of abstractions within those domains that you have. So you need to think very carefully about how we're going to structure your APIs in order for them to be very useful for the clients that are going to use them. And let's think about the example that we just saw in the previous video, that we created that status entity. That entity not necessarily needs to be a resource in our API. So there are a couple of ways that we can go. There is a very common pattern that we see in REST APIs, which is the action pattern, So you have power verbs, you have actions that you can use in your resources. So let's say you have the to-dos resource, okay? And you go to-do/id, and you have all those REST APIs you already know. And then you have an action over that to-do, So maybe you can, let's say you can buy the to-do, and then you have to-dos/id/buy. So that's an action that you are doing over that single to-do object. And that's very clear, that's very RESty, because it matches the rest of the, no pun intended, the rest of the REST API patterns. So it's going to be very easy also for the clients to understand what's going on. You can also have actions over collections. So maybe your action is not over a very specific to-do, but over the whole collection of to-dos. And a very good example that I always think about this, and I always use this in my APIs, is the people or users endpoint. And you have, let's say it's called users for simplicity. You have /users, and you have /users by ID, but you can also have /users/me, and that returns myself, returns the currently logged in user. That's a very useful route that a lot of the clients are going to want to use in order to retrieve the username and the name, the display name, and the profile picture of the currently logged in user. And the application doesn't know the ID of the logged in user, so it needs to have this action. And it's an action over the collection of users, because it's not over a single ID. In this way, you can create more complex APIs that run away from that crude that we get bare bones with the REST, and we can add more stuff. And that another thing that we could have done is to have nested resources. So let's go back to our status example from the previous video. So maybe status was not a good name for this resource, but we could have something like, say, operations, and then we could have a list of operations, and then you post operations, you create a new operation or complex operation, and then you get over operations, you get the status of that operation, etc. It could be an entity for us, And I think the most important thing to understand here is, what is a resource anyway? I mean, just because we say something to the database doesn't mean it needs to be a resource. Maybe it doesn't need to be a resource exposed in our APIs, and maybe we need to expose some things that are not directly going to be saved in the database. So that kind of considering is something that we always need to do with our REST APIs. And it's always good to think it through about these things so that you don't get bad API designs. And in order to decide what is a resource or an entity, I like to remember that we have a very common concept that comes all the way from database design and modeling and entity design in the backend, and we have concept of strong and weak entities. So I like to call a strong entity the entities that should have root endpoints. So those are the entities that do not depend on other entities in order to exist. So let's say /people or users, like we said before. That's a very strong entity. We have people. Our API exposes a collection of people. And that's a root entity. It doesn't depend on any other entity, And let's say to-dos. So to-dos could be a strong entity. Even though maybe the to-do has an owner, and that owner is a person, it's an ID, and they have a connection. They have a foreign key or a link between them. That's fine to say that to-dos is a strong entity. But then we can have weak entities. And weak entities have nested endpoints. That means is you cannot possibly have a root endpoint for that entity. So let's say people may have addresses, but addresses only make sense inside people. So I don't want my API to be able to display a /addresses, a list of all addresses registered in the API, because this information doesn't make sense outside of the context or the scope of people. It doesn't make sense because my API is not a Google Maps. It doesn't need to list all addresses that exist because we will only have the addresses of the registered users. Maybe you do have all addresses that exist, and then okay, you can have a strong address entity, and then persons have IDs of address, but that's a very weird design. Probably it will work only for very specific applications that are actually related to maps and things like that. If you only care to know where your user lives, you can have addresses as a nested endpoint. And then the APIs are like people/ID/addresses, and then you get a list of all addresses of that person. And then over these addresses endpoint, you have every REST API available to you. So the exact same thing that you have over /people, you have over /people/ID/addresses. So you can get one of ID, you can list, you can create a new, you can put, you can delete, and everything like that. And remember that operations that we had before. Or maybe our to-dos has a tasks subentity, or maybe it has an operations subentity, and those are weak entities, and they have nested endpoints. So those are very important considerations to make in your API design. So maybe in the database, the address entity is not very much different from the to-do entity. They both are tables in the database that have person ID as a foreign key, but conceptually they are very much different. Because a to-do exists independent of people. I can say that a to-do exists independent of the owner. I can list all to-dos of the application, but I can't list all addresses because addresses only make sense in the context of people. So, a very good consideration about this topic, we always need to think it through when we create our APIs, whether this should be a resource or should not, what should exist as a resource, what should be nested inside other entities or not.